Hello, this is for CIS 476, Software Architecture. My name is Maya Soleimani, and today we are going to be talking about the tree in SQL pattern. First, we're going to start with our motivation and forces, the reasons why we need to implement this pattern tree in SQL, why it's useful. There are a lot of examples in which a tree structure inside of a database, in this case SQL, and it's important to most applications that this data can be used against an efficient search and join operation. So in a lot of examples, and if you've taken a database course before, you will need to use certain reserved methods, selecting from different tables and joining them to satisfy that search. Moving on to forces, this is something negative. Loading an entire tree into memory before searching is not scalable. So if your memory is non-contiguous or in sequence, you may have to use costly traversal algorithms to retrieve data from the data structure. Relational tables are two-dimensional, so trees must be expressed using relational linkage. A popular example that a lot of us use every day is our file system, which is a tree structure and it does have a hierarchy. Having different hierarchical nodes where every node doesn't need to be parsed, it falls under a nonlinear structure, unlike a usual array or linked list, stacks and queues, which could be efficiently searched in a different way. We'll now talk about the intent of the tree in SQL. For every SQL tree structure, every node has its own unique ID and a reference to the parent node. So a popular example that we probably all use all the time if you are in software is the file system. For Windows and Linux at least, the file system has that hierarchy of how it stores information. For example, if you are taking a course and that is your root node, and let's say inside that course folder you want to have a folder for lectures and a different folder for assignments. That way you are able to organize your different files and you will not have to parse through, let's say, course C to get to a grandchild node in course A, which would be a description of an assignment, a turn-in of an assignment. Those things are not related, and with the tree structure, that helps you not waste search memory going through different data points that is not useful for your goal. Here is a generalized version of the different relationships between the parent, child, and grandchild in a tree. Of course, this extent can go beyond. File systems are quite large, but on a very low level, you will have your parent, who is the root and has no parents, is the only parent, and from that point on, each destination can have produce different files. Potentially, grandchildren can produce more children, but this shows the different hierarchies and relationships between those. We're going to look at an example of some code. I grabbed this specific one from LeetCode. It's under medium difficulty, and how it is described as each node in the tree can be one of three types. Leaf if the node is a leaf node, root if the node is the root of the tree, and inner if the node is neither a leaf nor a root node. Write an SQL query to report the type of each node in the tree. Return the result table in any order. So on the next slide, I'll show the example of the tree that I have chosen to use in my SQL table. The object is to identify which nodes in a tree have parents and have children and separating them into the types that they correspond to. Here is the tree example that I will be basing my input table off of in SQL. As you can see, for our input, it's categorized by the ID of the node, so 8, 3, 10, 1, 6, 14, 4, 7, 13, and its corresponding parent node. Of course, 8 is the only node without a parent because it is our root, and that should be categorized as such, as you can see in our output. And as you go down, it's just listing the different parents to the nodes, and this is how we will later on code the type of node it is and the relationship to whichever. So not much to do with the depth of the tree, just the inheritance relationship. So our output should look like this. 8 is our only root node, and then all of our inner nodes here, and then we have 1, 2, 3, 4 leaf nodes.
Here is the design pattern for a tree that we will later implement in SQL. The abstract node directs the current state of the tree node, which is an aggregation of our tree class, which represents the main heart of our database, in our case, the table with our nodes and their parent relationships. Our non-empty tree node is an aggregation from the tree class, represented in a 2-to-1 relationship. The binary search tree, which our example is based off of, the parent can only have at most 2 children to 1 parent. As for our associations of the class, the singleton pattern is implemented in the empty tree node class, as the node that's empty in our tree is our root, which will be the start of our subclassing and accessible from all clients in the tree.
So this slide, I went in a little basic, and I'm just showing the individual queries in SQL to create our tree to start, our table to start off with. So my whole database is called TreeInSQL, and that's where my table lives as well. I created my table as tree, and I have 2 different columns for that. After that, we want to insert all of our values. I showed just one query. You can also do it in the interface. And this is the basic setup that we want when we are doing the search. Now we're going to go through the main query of this problem and to classify each node as a root, inner, or a leaf. So I'm currently in my TreeSQL database, and I'm selecting everything from my tree table, which you can see. So in our tree table, we have our ID and parent ID column. We're then going to do a case statement. So when our parent ID is empty, we're going to classify that as the root. As we know, our root node will not have a parent. It will be the parent of the child, and then the child will be that parent of the grandchild, and so on. But the root node, there will be 1, and it's named the root, and there's 1. When parent ID is not null and the ID is in one of the parent IDs from tree, it will be the inner node. This is how we are going to differentiate leaf and inner, because at the beginning we already eliminated that it can't be a root node. As you can see from all of our inner nodes, it eventually applies as a parent later on to another node. If we look at leaf ID, any ID for leaf, it will never be a parent ID. This tells us that that node has no children, and therefore it's a leaf node. So once we grab the condition for the inner node, so meaning selecting from the parent ID, it must appear in ID and parent ID to be an inner node. Anything else will be leaf. So all the nodes that aren't null and that don't have children will be that leaf node. And I ended it here as class just to classify what kind of node it is. And again, we are selecting this from tree. To give a quick reflection of our SQL work, hierarchical data is a data structure where records are parents or children of other records of the same type. Some problems arise though. The duplication of certain data represented in multiple tables, additional levels of hierarchy being added requires more tables and overall can get duplicative. Having an adjacency list representing levels of different data types in one table by just adding one column and set it as a foreign key to the same table's primary key. So in our example, we did the typing as root, inner, and leaf, and this way when we want to access the nodes based on that type, it will be easier and we don't have to parse through two different tables instead. So to summarize, TreeInSQL has a multitude of purposes in real-world applications. We saw this with our example in SQLite, which is the application that I use to work through the database. We use it in our everyday file systems. Database being utilized for efficiency in search in hierarchical structures proved to be useful. It's definitely a savor of parsing through every single node to get through a specific relationship you're looking for. So whether that be at a job, if you're a certain sect of kind of employees, a team member, a custodian, or you are a CEO manager type, it is important to categorize and condense our searches, because when doing joins between different tables, we are able to have a lot of duplication and redundancy. So thank you for listening to my TreeInSQL topic. My name is Maya Soleimani, and I have listed a few of my references here below.